In this question, we want to use the vertical line test to determine whether the graph represents a function. And we're given this graph over here. It's a little bit crowded with my words. But before we go over that, let's just think about what the definition of a function is. A function is a relation such that for each element in the domain, there's exactly one corresponding element in the range. So we want to know whether this graph here represents a function, and this is what a function is. It's a relation. A relation is any set of ordered pairs. And a graph is showing us a group of ordered pairs or a set of ordered pairs. So every single one of these ordered pairs that are on this line are included. We don't include this one with the open circle. We do include this one with the open circle, and then all of the other ordered pairs that are on the line make up this graph. So we do have a relation, but we want to make sure that this is a relation that for each element in the domain, there's exactly one corresponding element in the range. So this is the key word here, exactly one corresponding element in the range. And to do this, we have a test that we call the vertical line test that helps us decide that if every element in the domain, every x, corresponds with exactly one element in the range, one y. So when we do the vertical line test, what you do is you draw vertical lines everywhere on the graph. I'm going to especially pay attention to this kind of strange spot where the two lines kind of meet each other, and then all the other vertical lines along here. Now, when you draw these vertical lines, what you're paying attention to is how many intersection points you have. Let me use a different color. So this vertical line has one intersection point, and this one has one, and this one has one. And what that's telling us is that we have an element in the domain, whatever this value is, and it corresponds with only one y value. Because it has one intersection point, it's corresponding to one y. So as long as all of the vertical lines only have one intersection point, then we have a function. So let's pay attention to this long line, long vertical line I drew. This one has an open circle, which is not part of the graph, and this one has a closed circle, which is part of the graph. So that vertical line only has one intersection point, and we only have one intersection point on all of these vertical lines. And so that is telling us that we have a graph that does represent a function. So this is a function, yes.
The next question says, use the vertical line test to determine whether the graph represents a function. So is the graph a function? So once again, we're trying to decide whether this is a function, this picture this time. And it goes back to that definition of a function again. Every x has exactly one y. And the way we do that with graphs is a vertical line test. So either you're going to physically do this or just in your head, but you want to imagine drawing vertical lines on every part of the graph, and you're going to pay attention to how many times those vertical lines cross the graph. So you notice here that I have a couple places where if I draw a vertical line, it crosses the graph in 3 places. So what that means is that I've got an x value. So for example, in this spot here, I've got an x value of 2, but y values of -4, -2, and 3. So you've got one x value corresponding to multiple y values, which violates the definition of a function. A function should have every x having exactly one y. So for this example, it's not a function because the vertical lines cross the graph in more than one place. In other examples that might be functions, if it only crosses the graph in one place, then it is a function. So for this example, it is not a function. The next example says, use the graph of y equals f of x to answer the following question. What is the y-intercept of f? What are the x-intercepts of f? So we want to make sure we know what a y-intercept is. A y-intercept is where the graph crosses the y-axis. So let's go look at this picture. Our y-axis is this vertical axis. And I notice that the graph crosses through the y-axis at this location right here. And if we read that location, it's 0, 0. So we have a y-intercept of 0. Then we want to answer the other part, which is what are the x-intercepts? An x-intercept is where the graph crosses the x-axis. So the x-axis is this horizontal axis here. And I notice that the graph, if I follow the graph, it crosses that x-axis here at -3.4. The graph then crosses the x-axis again here at 0, 0. And it crosses again at 9, 0. And if we continue on, even though we have this dot here, this dot is drawn as open, so that's not part of the graph. So we do have three x-intercepts of -3.4, 0, and 9. -3.4, 0, and 9 would be those x-intercepts.
Find the x-intercepts and the y-intercept of the function. We have the function f of x equals 2x squared minus 10x minus 3. I'm going to start by finding the y-intercept. It's usually a little bit easier. We can find a y-intercept by letting x equal 0. So let's pause there and say y. The definition of a y-intercept is where the graph crosses or touches the y-axis. The y-axis is that vertical axis, and if we think about all of the ordered pairs that are on the y-axis, all of them have an x-coordinate of 0. So that's why we let x equal 0 to find any y-intercepts. So I'll substitute a 0 into the function, and that will give f of 0 equals 2 times 0 squared minus 10 times 0 minus 3. And 0 squared is 0, times 2 is 0, 10 times 0 is 0. And then if we simplify, we end up getting a -3. So this function has a y-intercept at 0, -3. So then we want to find our x-intercepts. To find an x-intercept, we're going to let y equal 0. Let's pause for a moment to say why we're doing that. The definition of an x-intercept is that an x-intercept will be at a point where the graph crosses or touches the x-axis. The x-axis is that horizontal axis, and all of the points on that horizontal axis are going to have the y-coordinate being 0. So that's why we set y equal to 0 to find the x-intercept. Now in our equation we don't have a y, but we know that f of x is the same thing as y. So we're going to set f of x equal to 0. That's going to give us this equation, 0 equals 2x squared minus 10x minus 3. This is a quadratic equation, and I want to solve this quadratic equation. Now we have lots of different methods for solving quadratic equations. We have factoring. We have the square root method. We have something called completing the square. And finally, we have the quadratic formula. All of them have good value. I recommend learning them all. But my go-to strategy when I'm trying to solve a quadratic is that I usually start by trying to factor it. I solve by factoring because the answers look a little bit cleaner if we're able to factor it. And then if factoring doesn't work, and factoring doesn't always work with quadratics because not every quadratic can be factored, so sometimes factoring is not going to work. So if it doesn't work, then I go to the quadratic formula. And the quadratic formula is nice because it does work on every single quadratic, even the ones that can be factored. You can use the quadratic formula. So I'm going to start by trying to factor, and if that doesn't work, we'll use the quadratic formula. So when I'm trying to factor, I usually use the guess and check method. There are other methods for factoring out there. So I'm going to set up two parentheses, and the numbers that go in the front here need to multiply to be 2x squared. Now 2 only has one pair of factors, that's 1 times 2. So I'm going to use 2x and x. Then the numbers that go in the back need to multiply to be this last number. That last number is a 3, and 3 only has one pair of factors, that's 1 times 3. So we're lucky in this example that we have very few choices for factoring, and that can help us figure out if it can factor very quickly. So I'm going to try 3 times 1 like this. And what we need to do is we need to check to see if this guess is correct. And we're going to check by seeing if we get the right middle term. So if I multiply the inside two numbers and the outside two numbers, that's what makes up that middle term. So that would be 3x and 2x. Now 3x and 2x, if we add or subtract those, are not going to give us that middle number of 10. So this guess is not correct. I'm going to try one more guess, and I try that guess by switching this 3 and 1. So I'll put the 1 here and the 3 here, and let's try the middle two numbers now. 1 times x is x. 2x times 3 would be 6x. And if I add or subtract 6x and x, that doesn't make the correct number in the middle. So I've tried every pair possible in every combination, and I didn't get a factorization that works. So I know that factoring is not going to work on this example. So we'll move on, and now we'll try the quadratic formula. The quadratic formula works in this way. You can take any quadratic equation, which is ax squared plus bx plus c equals 0, and you can solve it with this formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let me erase where I tried to factor. And in order to use this formula, I need to know A, B, and C. A is the coefficient of the squared term. B is the coefficient of the x term, the linear term. And C is the constant. So we have A being 2, B being negative 10, and C being negative 3. And we're going to substitute these into the quadratic formula. So we're going to get x equals negative. There's a negative in the formula, and B is negative. So that's negative 10 plus or minus the square root of negative 10 squared minus 4 times A, which is 2, times C, which is negative 3, all over 2 times A, and A is 2. Then we're going to simplify using order of operations. So I have negative and negative 10, that's a positive 10. Inside the radical, I'm going to apply the exponent first. Negative 10 squared is 100. I'm going to do the multiplication next. 4 times 2 is 8. 8 times 3 is 24. And I have an even number of negatives, so that's going to be plus. 2 times 2 is 4. And let's continue here. Inside the radical, I have 100 plus 24, that's 124. And then at this point, I want to simplify the radical first as much as I can. So I need to think of the factors of 124. Now, I'm sure that there are a lot of factors of 124, but the ones we really care about are the ones that are perfect squares. And the reason why we care about the perfect squares is because we're trying to square root. So we're going to test out 4, which is 2 squared, 9, which is 3 squared, 16, which is 4 squared, and see if we have any of these factors. So I've got my calculator here, and let me divide 124 by 4, and that does work. It's 31. And 31 is prime, so it can't be factored anymore. So I'm going to use 4 times 31 as a factor of 129. So let's rewrite that 124. Let's rewrite that 124 as 4 times 31. Now we can apply the square root to these individual factors. And we get 10 plus or minus. Square root of 4 is 2. And 31, because it's prime and it's not a perfect square, we're going to have to leave that radical on there. So we get 2 square root of 31. The final thing that we're going to do to simplify is, this is a fraction. We always want to write our fractions in lowest terms. So we're going to look for common factors, and I notice that all of these numbers are even. So that's a factor that we're going to be able to cancel out, a factor of 2. So let's factor a 2 out of the numerator. That would leave 5 plus or minus square root of 31 over 4. And then we're going to be able to cancel a common 2 out. So this is 1 and 2. And we get our answer of 5 plus or minus square root of 31 over 2. Now, I've also seen some sources display this answer in one more way. And what they like to do is, instead of writing this as one big fraction, they like to write it as 2 smaller fractions. If you write it like that, you would have 5 over 2 plus or minus square root of 31 over 2. So either one of these last two are fine. They're in the simplest form. So we have 2 x-intercepts, and the x-intercepts are 5 plus and minus square root of 31 over 2, comma 0. So those are our x-intercepts. And remember earlier we found the y-intercept to be -3. Thank you for checking out my videos. Have a great day.